Section 3.2 Arithmetic Series. First of all, we'll discuss what is series. Series is a sum of infinite number of terms. Let's consider this sequence x1, x2, x3, comma, dot, dot, dot. And sum of infinite number of terms. So this is the sequence, and if we add this sequence plus dot dot dot, so now this is the series. We can simply write this sequence x k, so k equal 1 to infinity. So this is this way we can write a sequence and series. We can write a series using sigma notation. Sigma, so this is a letter from Greek alphabet, and we call here summation. Sum xk, k is starting from 1 to infinity. So this is, we can write the series in simple form like this. In here, command is given k equal 1 x1, k equal 1 x1, comma, k equal 2 x2, k equal 3 x3. Likewise here, if you see this one, so xk, when k equal 1 x1, then the command of this sigma is or summation symbol is to add, then k equal to x2, then add k equal 3 x3, likewise. So this is the short form we can write in a short form of the series, and usually we interest a partial sum. Partial sum, let's say S 3 or S, okay, S3. It means we only interest up to 3 terms, x1 plus x2 plus x3, or S4, x1 plus x2 plus x3 plus x4, but always consecutive from starting from first term. And likewise S2 is x1 plus x2, so S1 means the first term. So likewise we can write any partial sum Sn. It means x1 plus x2 plus x3 plus dot dot plus xn up to nth term. So we simply write this one in a summation note starting from 1 up to n. What is it? Xk terms. So Sn equal k equal 1 to n xk. So this is full sum series. This is the partial sum, and we are interested of this partial sum about the convergence and divergence. Right? If this one is confusing you, you can still leave it, but near future you may need to know. I will discuss an example. So I'll write the sequence, arithmetic sequence, 1, 3, 5, 7, and so on. So this is the sequence. And the series is 1 plus 3 plus 5 plus 7 plus dot dot dot. So we'll consider a partial sum of S2. What is the command is here? First term, add first term and the second term. What is first term? Plus and the second term 3. Answer is 4. S3. It means add first term plus second term plus third term. So 1 plus 3 plus 5. So this is 4 plus 5, 9. So likewise S10, then U plus U2 plus dot 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 up to U10. You have to add 1 plus uh, 3 plus 5 plus dot 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 up to U10 term. You have to add. Now, instead of adding up to 10 terms, so we need to know all the terms, and it is difficult task. So we have a simple formula, that is Sn is n divided by 2, 2a plus n minus 1 times d. So now you need S10, n equal 10, 10 divided by 2, 2a plus 10 minus 1 times d. To take 10 divided by 2 is 5, and 2 times a, you know that is 1, and 10 minus 1, 9 times d is in this sequence 3 minus 1, 2, 5 minus 1, 3, d is 2. So basically 5 times, this is 9 times 2, 18 plus 2, 20. So this is going to be 100. So when you add first 10 terms of this sequence, answer is 100. Let's discuss a bit further. Assume I want to add 135 plus 7 and 9. So instead of adding this line, I will rewrite this line like this: 9, then 7, 5. So I'm writing into the descending order from here, and then 3, and then 1. And I will add 9, 9 plus 1, I will add down, column adding. This is 10. This is also 10. 5 plus 5, 10. 7 plus 10, and 9 plus 10. So 1, 2, 3, 4, 5. So 10 times 5 is 50. And I use this strips 2 times. So then the addition of half of this is equal to 25. 50 divided by 2. What I did was 13579. I wrote 9753 to descending order, and then I add, then it will make one number, one fixed number, and times 1, 2, 3, 4, 5, and to get one half of this one strip. So I took the half of this number. So this is the concept we are going to use for adding basically. and that's how you get that n divided by 2, 2a plus n minus 1 times d formula. So I'm going to, so that's example 5. I think it's about the proof of this formula. So I'm going to discuss now. First of all, I write the terms, arithmetic terms as normal. So first term is a, and the second term is a plus d, and the third term is a plus 2d. So this is first term, second term, third term, and likewise, and the nth term is now 3, 2, 2, 1, 1, 0. So likewise, n a plus n minus 1 times d. So this is the sequence. This is the sequence. Now I am going to make this sequence to a series by up to n terms adding. So I put plus sign. So this is one term, the second term, and the third term, and this is nth term. So I name this one as Sn. So this is the partial sum up to n. So likewise 1, 3, 5, 7, then I wrote 9, then I wrote 9, 7, 5, 3, 1. The same way I am going to write a plus n minus 1 d here. So a plus n minus 1 times d here. And then this term. Okay, I will bring into the a plus n minus 1 times d. So that is the nth term. What is the term before this? It means a plus n minus 2 d. So this is the other term. So this is n term, this is n minus term. And what is the n minus 2 term? So a plus n minus 3 d. So now I am writing this one into descending order. So a plus n minus 1 d this one, and here again a plus n minus 1 times 2d, and here a plus n minus 1 n minus 3 times d. Likewise, the last one is going to be a, and one before that one a plus d, and the other one is going to be a plus 2d, and there are dots here. I will rewrite to understand this one clearly. So I wrote like this again. So a plus d, a plus 2, a plus n minus d. So now a plus d, a plus n 2d, a minus nt, n minus 2d, n minus 1d. So now it's like 1, 3, 5, 7, 9, 9, 3, 5, 3, 1. Now we'll add those two together. We are going to add those two together. So this is 10, and this all going to be 9, 7, 10, 10, 10. What will happen here? A plus n minus d, a plus n minus d. It means 2a plus n minus d. This is going to be 2a plus n minus d. Now, this term and this term, a plus d plus a plus n minus 2d, or a plus a 2a, and then I will expand this one nd minus 2d plus d. So then this will come nd minus d. So 2a plus, I'll factorize d again. So n minus. So this is also going to be 2a plus n minus 1 times d. This is also 10. This is also 10. The same number. And now this one, a plus 2d, a plus 2d, and a plus n minus 3d. So then this is a2a, and you can see now 2d and this is minus 3d. This is cancel out, and this is going to be remain n minus 1d. You can expand and see. So this is 2a plus n minus d. And the last one, if you look at, and a plus n minus 1 d plus a, it means a plus a, 2a plus n minus d. So this is going to be 2a plus n minus 1 times d. So now you can see that 1, 2, 3, 4, 5. So 5 times 10. So likewise, now how many times these terms? 1, 2, 3, likewise n terms. N terms 2a plus n minus 1d term. And Sn plus ns is 2Sn. And we need not 2Sn, we need Sn. So then we'll divide by 2, n divide by 2, 2a plus n minus 1 times d. So we discuss about the sequence, and we discuss about the series Sn equal add, and we found out uh, a short formula for to find the addition of nth terms. And we know this is what is this term? This is the last term. I can make this last term here 2a. I can write a plus n minus 1 times d. Now this is smash, this one and this one. This is the last term. If I take this last term as L, so then Sn equal n divided by 2 a plus L. We'll discuss example. So this is arithmetic sequence, and I turn this one to a series, and 1, 2, 3, 4, 5 terms. I want to find S5. First 5 terms, sum of first 5 terms. I know the formula Sn equal n divided by 2, 2a plus n minus 1 times d. Then I want to put instead of n, I want to write 5, n equal 5. So S5 equal 5 divided by 2, 2 times a is the first term, yes, 2, plus n minus 1, n is 5, that is 5 minus 1, 4, and d, 4 minus 2, 2. So this is going to be 5 by 2. This is 4 plus 8. So 5 by 2 times 12. So this is 630. Or I can use, instead of this formula, I know first term and I know last term. So I can use n equal n divided by 2 a plus l. So then n equal 5 is 5 equal 5 divided by 2. A is 2 and the last term is L is the last term. Last term is 10. So 5 divided by 2 times 12, 30. What will happen? I want to find 5 terms, but I don't know the terms. Last, only I know 2, let's say 2 terms. So that is enough to find the first term is there a equal 2 and d equal 4 minus 2 is 2. Then we can't, since we don't know the last term, we can't use this formula. Then we have to only use this one because we don't know the last term. Example 6 in the book. So we want to find the first 50 terms. Sum of first 50 terms. It means we need to find S50. So we have Sn equal n divided by 2, 2a plus n minus 1 times d formula. So n equal 50, S50 equal 50 divided by 2, 2a is 32 plus n is 50 minus 1 times d, 20, 27 minus 32, so that is going to be minus 5. So we have to solve now 25 times, 64 times, 64 plus 49 times minus 5. When you solve this one, you should get the answer as minus 4525. Example number 7. Find the least number of terms required for the sum to exceed to 2000. So least number of terms we need to find. So if we take S1 is 4, is less than 2000. S2, that is 4 plus 9 equal 13, less than 2000. S3, that is 4 plus 9 plus 14. So basically 27, less than 2000. So likewise S4 also maybe is some figure less than 2000. Likewise after some time, let's say after Sn, this figure is going to be greater than 2000. So we need to find this n term now. Now this Sn mean n divided by 2, 2a plus n minus 1 times d has to be greater than 2000. So basically I'll multiply by 2, n times 2a plus n minus 1 times d is greater than 4000. N as it is 2a. Do we know a? Yes, a is 4 and n minus 1 times d is 5. 9 minus 4, 5. uh, greater than 4000. So this is in 8 plus 5 in minus 5 greater than 4000. I expand this one 5 in mind. So n plus this is 5 n plus 3 greater than 4000. It means 5 n square plus 3 n minus 4000 should be greater than, I bring to 4000 here, 0. Now this is the quadratic equation y equal. So when you draw a graph, so you can draw a graph and let's say some here. So after some n, this value, after some n, this value is greater than 2000, greater than 0. Basically we have two areas, this area and this area from here. If you know this one, then from that uh, term onwards, it's going to be more than 2000 when you add. So instead of going graph, we can look at by simply with the formula. I can see in the example they discussed and they found out two answers with the quadratic formula. N equal minus 3 plus or minus n plus 80,000 I can see on the book, and they have two options, n equal 28.0 or minus 28.6. So when you draw the graph you can see one is one value is going to be here, that is 28, and this one is minus 28.6. So after this onwards, this value y value is greater than 0. Greater than 0 mean y value is greater than 0 mean this expression is greater than 4000. This expression is greater than mean this expression is greater than 4000. It means this expression is greater than 4000. It means this expression is greater than, it means this expression is greater than 2000. So simply you can tell that this is 28. So n has to be greater than, the minimum one is n equal 28. And all the numbers n greater than 28, it is exceed 2000, this boundary. So this is S28 terms is greater than 2000. Then we know that S29 definitely it is greater than 2000, and so on.